All right, I'm going to try showing you guys how to do an AWS test plate. This is the plate itself. It's 7 inches long. It's a standard assembly. We have some in the school that are cut for your practice, and then there's wider plates that are used for an official test. The plate has a backing bar. This is a 1-inch backing bar that goes in. You can see with the plates, it's a little bit longer than the plate is as a whole. The backing bar goes on the bottom side, like so, and ultimately, when you're welding, it will look like this. There'll be a gap between the plates, and the weld joint goes down here. The rod will travel down between these on the root pass. Most folks will choose to weave a little bit like this. That weave pattern needs to be relatively quick so that the plate, the puddle, actually bonds both sides. Otherwise, you could actually end up in a situation, if I exaggerate, if I went from here to here to here to here, so on and so forth, between those weaves, I would actually miss little tiny pockets, and we don't want to do that. So what I'm going to do first of all is I'm going to prep these plates. I'm going to take a grinder, I'm going to grind the edge up, I'm going to grind the back side up, and I'm going to grind up the backing bars. So let's do that right now. You're looking through a welding lens, so the color is a little bit funny, but this is how I'm going to try to record this. So here we go. I'm going to grind this up. As much as possible, I'm going to try to do this in real time. It should not take a lot of time to weld one of these plates. The surface just has to be cleaned up a little. Same on the back side. Remember, the weld will melt into that back edge, but you're not welding out onto the edge. And then same thing on the top. The top, you are welding out onto the edge a little bit for your cover passes. But you don't have to go berserk with the cleaning. They just need to be free of oil and dirt and debris, but they don't have to be polished to a mirror finish. The backing bar is being welded directly to, so it should be fairly clean. So again, there we have the backing bar. I'm going to get 2 extra backing bars to hold the plate up so it sits level. Right now, if I set the plate on here, it's actually tipped down. You can see that a little bit in the camera from this point of view. We actually have a fixture in the school that will hold the plate in position. But to be perfectly honest with you, it's not necessary. It's just easier, and I'll show that fixture later on in this video. So for the plates themselves, I want to get them tacked up. I want to put a little tack right here on this end and a little tack here on this end. I don't need to go crazy with it. I want to make sure that the backing bar is underneath the plate completely. I want to have enough room to tack. I don't need a lot of extra room. I just want to make sure that I'm welding to the center of the backing bar. If I'm too far off on one edge, I could actually burn a hole through the backing bar. So I'm going to go ahead and I'm going to tack this up. Get my lead. I'm going to put a tack on one plate on both ends first. I'm simply going to hold down on this. Again, just a small tack there. I'm going to go to the other end, and I'm going to do the same thing on the opposite end. Now I'm going to double check the gap. The gap between the plates wants to be about 1/4 of an inch. A little bit wider is not a big deal. You can use a plate itself as a spacer, but ultimately I want to make sure that I have an even gap and that I don't have gaps under the bar. Right now the plate is tight to the bar. Sometimes the plate can be bowed a little bit like this, and you end up with a gap under the plate. We want to avoid that. And the garage, just because I'm on camera. And then ultimately I'll go back and tack the other end. I see the gap is reached. So I can tell you that this gives me an appreciation for those guys on the internet that do this all the time. Welding with a camera between you and what you're working on is a royal pain in the butt. But here I have it. I'm going to remove these backing bars or allow them to move. I'm going to blow off the dirt and the debris with a little compressed air so I get a good ground. And there goes the camera shaking again. And I'm going to set the plate down. Now the idea here behind this is to weld this plate up so that it is 100% weld. I want full penetration weld. I do not want to have a situation where I have a gap in there or that's going to trap slag or anything like that. We're simply trying to create a piece of steel, a single piece of steel out of two pieces of steel. The backing bar eventually would be removed, so while it is technically a third piece of material, we're not going to count that here. Alright, I got a little camera repositioned so I can actually get the rod and the slag hammer underneath the plate. So I'm going to begin to start welding. I'm going to keep my rod angles as close to natural as I can with the camera being in the way. I may end up having to stop a little bit short. My drag angle is a little bit extreme, but it kind of is what it is at this point. I suppose I could slide the plate down to get it out from underneath. Now I'm going to use these tabs on the end. BIW, they would refer to these as runoff tabs. Basically, it's a tab that's added to the end of a plate to allow you to weld, start off the plate and to run off the other end. In this case, it's also the backing bar, so it's technically just a backing bar, but you'll hear me say the term runoff tab frequently because I've been programmed that way over the past 28 years. So I'm going to go ahead and try to put the first pass down. We'll see how this works. Then I'm going to get that pedal started. I'm running 130 amps. I do not want to get slag in front of me. And I'm going to weave back and forth quickly. You have to have the discipline to stop if something goes wrong. You're allowed to grind on these tests. My goal is to not grind. But if something goes wrong, you have to stop. You do not want to bury slag. You do not want to continue working if the angles are incorrect, if you're getting a lot of spatter, or anything like that. So I'm about, my hand's touching the bench, my rod's getting too vertical, and I'm just going to stop. I'll set my wire stub off to the side. I'm going to chip the slag off just where I stopped. I'll move the plate up a little bit so it's in better view of the camera because my rod will clear. And I'm going to chip this off. I'm going to wire brush this out real quick. If you want to, it's not necessary. A little compressed air to blow that away. And again, I'm just going to pick right up with air where I left off. I do not want to leave a gap here. I want to start right where I stop. So again, I'm going to try to strike my arc right up here, and then I'm going to just carry it down into that puddle. In this case, I'm not going to go back into it. I don't want to bury anything that I might accidentally trap when I strike my arc. Again, constantly moving left and right. The arc itself, not just the puddle, can melt into the corners of that backing bar. When I get to the end, I'm going to come off that tab. I'm getting a little bit of spatter here because of magnetic arc flow. So I'm just going to stiffen my rod up, straighten the rod up, and I'm going to weld off, and then I'm going to stop. We'll chip the slag off of this. We'll let it cool down a little bit. It's a little bit red. And then I'll wire brush it and I'll put on the second layer. Now on the second layer, I'm not going to weave a single pass. I'm going to run 2 passes. And the reason for that is I want to limit the amount that I weave because I may trap slag. If I'm running flux core, you can weave a little bit more with stick at 130 amps. I probably could weave more than I am, but stringer beads are what a lot of companies want to see, so that's what we're going to do. So she's cooled down, so I'm going to chip off this slag. A little bit hard right here because it's still hot. Again, I'm going to scrape with the slag hammer whenever I can. I don't want to leave chip and hammer marks all over the plate. Just unprofessional. Carefully look, there's a little bit of slag right there. I don't know if you can see it in the camera. I'll wire brush that off, and then I'm just going to clean off the desk so that I get a good ground. Okay. Any spatter that you have on the surface should be removed after each pass. Weld spatter should always be cleaned off from a test plate. Okay. And assume, unless you're told otherwise, that grinding on the surface of a test plate is prohibited. Again, I'm going to pick up where I left off. For this demonstration, I'm just going to use new electrodes each time. On a normal butt, I would not do that, but just to keep the continuity of the camera, I'm going to do that. So here we go. I'm going to run the pass down this edge. I've got the rod angled a little bit in that direction. I want to burn directly into that corner. Here we go. Start way out on the end. Whoops. B. Try that again. There we go. Plate. I'm going to finish this off very close to the end. And again, I'm not going to stop when I get to the end of the plate. I'm going to travel past it and then build that up. Okay. I want to take the time. Again, I burned almost the entire electrode. That's why I started with a new one. I know on these plates I'll use basically an electrode per pass. The slag is already peeling up in the middle, which is good. That means I don't have any undercut. And again, I'm going to wire brush this out. Now for this particular plate, my next pass needs to come into this corner. I want to make sure that that valley that's in there is about the width of the rod. I don't want to get to the point where I'm trapping slag. Now, only because of the camera, I'm going to turn this around and I'm going to weld. I'm going to face the other direction. I wouldn't normally do this. I could lean over and see the other way. But again, because the camera and the support for the camera is in the way, I'm going to turn this plate around so that I can have my rod angled this way instead of the other direction, and the support, the sucker tube, is all physically in the way. So I'm going to go backwards. Same thing. Nice controlled pass down in that corner. I'm at 130 amps, so I may have to back that off as I get more filled. Again, grounding issues, they are what they are, folks. You never know when you've got a good ground or a bad ground. You can feel free to let your plates cool, but again, on a plate like this, there is no heat input restriction. There is no interpass temperature that has to be followed. It's mild steel. It can be welded without stopping. Now, I don't know if you can see this or not. I'll try to show. There's a little bit of a valley in the plate right here. So I'm going to put a pass more or less down the middle. I'm going to turn the plate back around to where it originally was. I'm going to put a pass down the middle. This is going to take a little bit more to fill, so I'll probably burn more than one rod. Also, the angle that I'm filling is not a sharp V anymore. It's wide, so I can manipulate the puddle a little bit. I can move the rod around, or you can run straight stringer passes. It's your call. Here we go. That's a common problem. I'll give this a second to cool. I can see the slag cracking in the middle. That means it's cooling off. Again, I'm going to use my wire brush handle to hold this down. I don't know if you can see it on the camera. I guess it's just on the camera, so I don't burn my gloves. And I'm going to scrape the slag off. Means it's not done yet. The weld is, in all reality, stronger than the plate, but we don't make that assumption, and we do not partially fill the plate assuming that the weld is stronger and knowing that, well, it's stronger, so I don't need as much of it. We need this weld to be the same thickness as the plate. We are allowed a little bit of reinforcement, a little bit of extra weld. The amount extra that you're allowed is typically limited by the thickness of the material. So, on your AWS plates, whether it's a limited thickness plate, which is what this is, the plate is 3/8 of an inch thick, and that qualifies you to weld on material that is as thin as 1/8 and as thick as 3/4, okay? An unlimited thickness plate, plate's a little too hot for me to hold it and hit that little spatter ball, so I'm going to leave it for now. An unlimited thickness plate for AWS is a 1-inch thick test. The test is only 5 inches long. This plate is 7 inches long, so it's a little shorter, but it's 2.5 times thicker. And that would qualify you to weld on material as thin as 1/8 and as thick as, well, unlimited, hence the name of the test, unlimited thickness. On those tests, you're allowed 1/8 of an inch of reinforcement. Right now, you can see that the weld is still below flush. What I want when I'm done is I want a maximum of 1/8 of an inch of weld above the top of the plate. BIW, you would only be allowed 3/32 of an inch. That's 25% less, or it's actually 3/4 of 1/8. It's, I guess it's 50% less, technically. No. 33% less. Anyway, I got to do my math in my head, but it's less. If you take a 1/8 rod and a 332 rod, the 332 rod, that's the maximum reinforcement you're allowed at Bath Iron Works in the welding school. Out on the ship, you're allowed more than that based on the material thickness. Thicker the material, the more you're allowed. Basically, the more there is, the uglier it gets, and it's just wasted material. So again, I'm going to run a pass down this side, and then I'll put 3 passes down to cap it off. Now keep in mind, on your AWS test, you are allowed to do some grinding. So if you get a bad spot or if you get a little extra weld on your fill, you could grind it down before you dress it off or cap it. I was trained at Bath Iron Works. You're basically not allowed to grind. And that means that technically you are allowed to grind, but it's very, very restrictive. Here I could, in theory, put a pass in and grind the entire pass out if I think it's garbage. And I could continue to do that as long as I can get the plate welded up in the 45-minute time limit. That's right, there is a time limit. Right now I'm at 20 minutes and 11 seconds, according to the camera. BIW, you're allowed to grind 2 spots on this pass, a maximum of a ½ inch each. That does not mean 1 spot an inch long, okay? And that grinding is restricted and limited by the instructors. Now I'm going to move this plate down a little bit so I got better access for the dress. The cap needs to be more or less straight up and down. Again, I don't want to hit the camera, so I apologize for it being off center. But I'm going to cap it off with 3 passes. I'm going to scatter. You do not want to have steep drag angles. You will get scatter. And I get near the end, I'm getting a little magnetic arc flow. I'm going to wash this back up in to fill that, and I will stop. So there we have it, folks. That was 25 minutes and 6, 7, 8 seconds clicking by. I will wire brush this off. Weld it in real time. It should not be difficult at all to weld this in 45 minutes. When you're all done with your plate, you always turn a test plate in pretty, wire brush it up, chip off any loose spatter.